This how-to video explains infrared spectroscopy in a simple manner. Now if you look on the internet, particularly YouTube, there are a heap of videos about IR spectroscopy, and most of them detail the IR machine, how it works. And frankly, you don't need to know anything about how the machine works. What you do need to know is the principle behind which infrared spectroscopy produces images which can be interpreted to give information about molecules. And cutting to the chase, it's basically this, that all molecules will absorb infrared radiation, and when they do so by making the bonds between the atoms in the molecules vibrate. And there are two types of vibration. The first vibration is a stretching vibration. So we've got a carbon atom here and a hydrogen here, and at a particular frequency in the IR spectra, this bond will vibrate. In other words, these molecules will vibrate more than they do in normal conditions. And at that point, the molecule absorbs the infrared radiation. And the other type of vibration is a bending vibration. Again, in this case, we've got hydrogen, carbon and hydrogen, and we can get these bending in and out. And again, that occurs at a particular frequency in the infrared spectrum. So, two types of vibration, a stretching vibration and a bending vibration. Now, the amount of vibration depends upon basically three things. The bond strength. So if we have a carbon-carbon double bond, it's going to be stronger than a carbon-carbon single bond, obviously. So a carbon-carbon single bond will vibrate more than a carbon-carbon double bond, and it will happen at a different frequency in the spectra. Same principles, the bond length. If a longer bond length will vibrate at a different frequency to a shorter bond length. And finally, the mass of each of the atoms involved in the bond. So a carbon-carbon bond will vibrate at a different frequency to a carbon-hydrogen bond. A carbon-oxygen bond will vibrate at a different frequency to a carbon-hydrogen bond. And that's essentially how it works. We're talking about absorption through the infrared spectral range, and wherever that absorption occurs, it's because of a bond absorbing the energy at that particular frequency, and those depend upon these three things. For most first year A-level courses and questions related to this topic, you're really going to only be asked about three particular groups, and that is an OH group, so the absorption of an OH group, a C double bond O group, a carbon R group, either as an aldehyde and a ketone, but could also be part of a carboxylic acid, and indeed carboxylic acid itself. So most A-level, first year A-level courses really concentrate in identifying these groups in molecules. So let's now look at a typical trace pattern you get from an IR spectrum, and this is the sort of thing that you'll be presented with in the question. You'll see that down the side there is the vertical axis, which is a thing called transmittance, and you go 100% down to 0%. And basically what happens is when you put your IR energy through the sample, it travels through, and we give it a range of frequency from the start of the IR spectrum range to the end of the IR spectrum range, and that is associated with the bottom scale, which is called wave number. And again, you don't really need to know about what wave number is, you just need to know that the bottom scale is wave number, and the vertical axis up the side is transmittance. And what we get is we get a set of peaks, upside down peaks, which represents the energy absorption as the IR passes through the sample. So as it passes through, at certain points the molecules or the bonds between parts of the atoms in the molecule start absorbing the energy. When they absorb it, we get a energy absorption, so the transmittance decreases. In other words, some of the energy is taken into the molecule to cause the bonds to vibrate. And then as we move up the IR spectrum, it stops vibrating, and then a different part of the molecule bonds or starts to vibrate, and then doesn't, and then again a vibration, and all the way through to the end of the spectrum. Now, this is quite a daunting picture, but the real way to start with anything like this, and this is a sort of Smith rule of thumb. I'm just going to grab a pen here, and I'm going to draw some lines on my picture, and I'm going to draw a line across from about 45 all the way across here, and I'm going to draw a line from about 1500 all the way up here, like that. And then what I'm going to do is I'm just going to colour in this lot, because I'm not really interested in any of this or any of this. Now this section here, let's grab a different colour pen, let's get yellow. This section here is called the fingerprint region, and as far as A level is concerned, you are not interested in anything in this region here. That's a pattern of the carbon-carbon absorptions in the molecule, and it can be used as a fingerprint through computer analysis to identify the structure of the molecule. But for all intensive purposes, it's of no use to us. The only section that we're interested in is this section here. So if we have a peak here or anywhere here, we are going to try to identify it. Nothing up here, below or above 60, and nothing over here whatsoever. Now in an exam, most exam boards will give you a data sheet, or there will be a data sheet attached to the question paper. And as I've said, the real three groups that you are going to be asked to identify are a C double bond O group, which is an aldehyde ketone or carboxylic acid, or an ester. And you can see this wave number range here. And we'll discuss that, and I'll show you something about that in just a second. The OH group of a carboxylic acid, and again we've got the numbers here, 2500 to 300, very broad, and again we'll look at that. And the OH group in alcohols and phenols, and again we've got a wave number. In other words, we've got a way of identifying these functional groups in molecules from an IR spectrum, and the easiest way to do that is with examples. So let's have a look at an example. Here is example 1, and following my rules I'm just going to draw a few lines on it. There we go. So I'm interested in none of these regions. You can see now I've got a peak here, and the peak is, if we look up on the wave number, the peak is around about 3,200, but it's broad. It's a broad peak. Now if we look at our data sheet over here, 3,200 to 3,500, we have a broad peak. So this suggests that this compound is an alcohol. And that's all we can decide from this IR spectrum. That's the only piece of information that we can glean. Now, in an exam question, we might have other information around empirical formula or mass formulae, and other information about chemical tests. But this IR spectrum only shows us that we have an alcohol group in the molecule. Let's progress forward to this. Again, I'm going to draw some lines. And if we look, the only thing here of note is a peak at around about 1700. If we look at our data sheet, a peak at 1700 suggests that we have a C double bond O group. So we've got either an aldehyde, a ketone, carboxylic acid, or an ester. So somewhere in there there's a C double bond O. And again, as with our first example, all that we can say from this IR spectrum is that we have a C double bond O somewhere in the molecule. And let's look at our final example. Again, I'll draw some lines. In this case, we have two peaks. We have this one to consider, and we have this one to consider. And this is a broad peak around about 3,000, and this is a narrow peak, a very defined narrow peak at about 1,700. So if we look at our data sheet, a broad peak around about 3,000 suggests we've got a OH group which is on a carboxylic acid, and a C double bond O group around here suggests that maybe this particular molecule contains a carboxylic acid functional group, because it's got the broad OH group corresponding to a carboxylic acid, and it's got the C double bond O group in the region also corresponding to a carboxylic acid or an alcohol. And that's IR spectrum basically in a nutshell. I stress the point that I made at the start. You do not really need to know anything about the functionality of the IR machine. You just need to know the principles of how it works. I hope this video has been helpful. Thanks.